Shouldn't have wrote that. C of x. So what, not 6,000, 6 million. What if we took the integral from 6 million to 7 million of that derivative function? What would that tell us? If we took the integral from 6 million to 7 million of the derivative function, what would that tell us? Yep, of C prime of x. The integral of the derivative, what would it tell us? Talk to somebody around here real quick. I know you're in IB. You're good at verbalizing what's going on. That's what they teach you in IB.
That's not dollars.
No, that's not dollars. That's units. That's not dollars. That's units.
I think it would be the price. Yeah, I think it might be the price increase.
Brian, you're really where did we go for this?
All right, volunteer. Somebody besides Monahan. I know he's got this. Somebody else. Brent, you were looking at me like you really wanted to answer this. No? Somebody else.
Well, I can answer it.
Okay.
It's probably the change in amount of iPhones.
Change.
The sum of the amount of money it takes to make that one.
Okay.
Probably.
Change in the cost of iPhones. You had that the first time I was writing it down.
Okay.
Can you say what you said second? No, that might have been better.
The total amount of money it takes to make that many iPhones.
Okay. The total amount of money it takes to make from 6 million to 7 million iPhones.
How would it change between 5?
One at a time.
How would it change?
Brandon, yes.
Is it saying like the price increase between making 6 million iPhones and 7 million?
Right. Now, I do want to be careful. It's not going to be the price the consumer pays. It's going to be the price to Apple. Yes. Now, kind of weird. What's not included in that? No, there's going to be taxes because if you make it in China, there's going to be some kind of tax to import it to the United States, more than likely. It's called an import tax. Import taxes are designed to protect domestic producers because if they can make something cheaper overseas, that costs America in jobs, money. So they charge an import tax. When they have free trade agreements, that's when they say, yes, you can import stuff for free into our country. We'll let you import stuff to their country. We do not have one with China right now. That's the Trans-Pacific Partnership that is currently under debate in Congress, but it has not been approved yet. Like NAFTA was the one in the 90s. It's a free trade agreement between Mexico, United States, Canada, where they can freely import things from Mexico to the U.S., Canada to Mexico. It is. And to be honest with you, it is why some jobs moved to Mexico that previously had been here and vice versa. Okay, what is not included in that? Is the cost to design the iPhone? No, because that's going to be something that it costs you to make what iPhone? The very first one, right? You cannot make the first iPhone unless you pay a whole bunch of expenses first. You have to design it. You have to test it. What else do you have to do?
Advertising.
Advertising may be in this because you might, like, say, for example, Apple can sell 6 million iPhones without doing any advertising whatsoever. And if you're old enough to remember, initially, Apple did no advertising on the iPhone because you had to wait months to get an iPhone. Why would you advertise something that people are waiting for anyways? They only started doing that when the Androids really started competing with their market share in the smartphone market. BlackBerry used to be their only competition, and BlackBerry would have basically the business end, and iPhones would have the personal end. So there may be advertising cost in this because they may have to advertise to sell that another millionth iPhone. What else is not included in this, though? Product testing, yep, because they got to do that to sell the first one. Probably don't have to do more product testing to sell another million of them. Brent?
You need a plus C.
Plus C?
That's just accounting for all that extra charges.
It would be, but remember when we have the definite integral, that's not going to be a part of it because we're going from 6 to 7. But you're absolutely right. That would be the plus C that it cost us to make the first one. Good understanding of what that means, though. What else? Testing's not included. Designing, development, right? All of that stuff's not included in this. So kind of odd. Like I was mentioning last time, it feels like you have to make those costs up. But those are already gone. You cannot get that money back. It really doesn't matter if you sell this another millionth iPhone or not. For all that development cost, you've already had to pay all that. So marginal cost pricing is just looking at how much it takes to make one more, not how many it took to make the total of them. So we go from 6 to 7 million. It's not including those initial costs. When you find this, this is called the marginal cost. And let's even put that in. The integral from 6 million to 7 million of the rate of change of the cost function is equal to the marginal cost to make the next 1 million units. On a business perspective, that's like your break-even point. Like you will not make them unless you charge that much at least. Now, is that going to be the same as for the first phone? No, your first phone's the most expensive. The first airplane, the first 747 was the most expensive one to make. The last one was the cheapest one to make. So, connecting this to the business world or what you'd have to do, or if you end up tutoring business calc, this would be something that you'd have to explain and get to people. You're not looking at the total cost. You're just looking at just between 6 and 7 million. How much did it cost? Storage.
So if you're looking at between 6 and 7 million, how much does it
Yep.
cost? Would that be the same as if you're looking between 5 and 6 million? How much does it cost?
Possibly, because they might have got a better deal to make the 6 millionth, the 7 millionth, because then they're buying in bigger quantities or they're buying in bulk. Or, Monahan, I'll let you.
Oh, I just said it was not necessarily just the price could change based on how much you're making.
Yep. And the later you get in production, like the end of the iPhone 6S line, those suppliers, they've already designed the part, they've already made the part. So they've ignored those sunk costs, and they're just saying, well, if I make 5 more, how much is it going to cost? And that's what they need to make up. So those will end up being probably at a lower price. Like right now, 747s are basically at the end of their production life. Like 4-engine airplanes are almost done. So they're selling them super cheap because they've already designed it. They've already assembled the manufacturing line. They've got all the stuff to make the parts. So now they just have to say, well, how much do I have to buy to actually make this part? As long as I make more than that, we're good to go. Like we would make more money on that, which would probably be cheaper than the first one because they had to buy all that stuff, train all those people to make that first one. Josh.
How do I print off of this? That's not my question.
I'm in the middle of teaching right now. Ask at the end. But I'll let you hook up to my printer. So that's all we got to do. Need to do an example? Of course we do. Why not? Let's take a look at what should we do?
Homework problem.
Just the, oh, you want to do the marginal cost homework problems? Lazy kids. You don't want to do more work? Okay, pick one, Ellie. Pick one.
We don't have them.
17.
Can we just start with 16? Because we don't have to do them all.
16? All right, 16. So basically, please do my homework for you instead of learning it. Let's learn it and get a homework problem done.
Well, you did you did it time, so. And then you said it'll make you
I'm gonna switch classes with Chim this period. The marginal cost of producing X tablets is C prime of X. Yep.
So is the net change, is that when you have the absolute value around it?
Hold on just a sec. 1, 2, 3, 4. Okay. And we've got to find the cost of producing 3,000 units if the setup cost is 90,000.
Is that 1x?
Can you speak the paper up a little bit?
0.00001. Yep, I'll scoot it over. X squared.
Oh, x.
Okay, so the setup cost is $90,000. And what else do they give us that we have to know? If production is set at 3,000 units, what's the cost of producing an additional? Okay, so first they want to know what is the cost of producing 3,000 units if the setup cost is 90,000, and part 2, marginal cost for 3,200. Okay, now questions. Brandon, what did you have?
No, we haven't learned anything today. We need to keep working on this.
All I want to know is you emailed about the copy.
Yes, it is. I forwarded it to you.
Yeah, does it sound like it's about to explode?
Yeah. Good.
I apologize for interrupting your learning.
Oh, I'm sorry.
Get back to
No,
work.
no.
Yeah, turn back
It
around.
wasn't
No.
directed at you. It was
No,
just
no, no,
towards
no.
the
Get back to work.
situation.
It's directed at Mr. Beckman because he just chanced me. Yes, he does.
You're right. Look at us chatting.
Yeah, look, it's like one line of writing.
It's a social beast, dude.
Okay, yeah. We're chatting about marginal cost integrals. All right, so let's take a peek. So the first part, they want to know the total cost for the first 3,000. So total means we're probably gonna have to take a what? Integral. So we're gonna take the integral from where to where though? Well, yeah, to make 3,000 means we started at 0, we got to 3,000. Now you're saying to yourself, where does this come into play? Actually, Brent talked about that. That 90,000, that's gonna end up being our C value probably. But let's take the integral. So we got 120 minus 0.06x plus 0.00001x squared
Wait,
dx.
Is that 3,200?
3,200. Yes, marginal cost for 3,200.
Is that what we're doing the integral part?
The first part is they want us to find the total cost to make the first 3,000. Then they want us to find the marginal cost for the next 200. Okay, now the nice part about this, they're usually what kind of functions? Polynomial. So the nice part is the integral part's usually pretty easy. So we take the integral, that's 120x plus 0.06x squared over 2 plus 0.00001x cubed over 3. We're going to take that, plus c from 0 to 3,000. Thank you. Anybody want a Wall Street Journal? All right, now I put the plus c in there, but let's talk about where that's going to come into play. So there is a constant of integration that we can move up or down. The nice part is it usually cancels each other out. Just to make 0 to make 3,000 is going to cost us 90,000 here regardless. So let's talk about how that plays in. But let's plug in first. Plug in 3,000.
The setup cost is that's like
But they ask us for not the marginal cost in the first one. They ask us for the total cost.
oh, so is C the setup cost?
C would be the total cost. Now it may end up canceling each other out, but let's see what happens with that.
So at the end when you get this,
Yep.
just add 90,000 to it or what?
And that's at the end of the day, that's what we're going to do. So this is the marginal cost from 0 to 30,000. We will have to add the setup cost to that to get the total cost. Because if it costs us whatever we get, let's say $1 million to make the first 3,000 and 90,000 to set up, that million did not include the setup fees. It just included the marginal cost, like to make those. So we'll have to add that in. Yep.
But it doesn't make sense that you put the C in. because what-
Fine, I'll erase it. We'll bring that up at the end then. Okay, so plug in 3,000. What I
That's just minus 0.06.
That's a minus. 3,000 minus 0.06 times, okay, let's make it 0.03. We'll cancel that out. Times 3,000 squared plus 0.00001, 3,000 cubed over 3. Now, I'm not even writing the second part because when we plug in 0 to all these, what do they become? 0. Throw that in your calculator real quick, see what we get.
So why are we doing it from 3,000 to 0?
Because they want to know the total cost of making the first 3,000 chips, or the first 3,000 dogs. Dog breed, seriously, buy a Labradoodle. They have a Labradoodle. You can buy a kid for less than that.
Okay,
Are
so
those
then when we do,
Yeah.
then when we do 2,200 and then 2,000 for our integral.
Our integral goes from 0 to 3,000. Oh, for the second one, yeah, it'll be from 3,000 to 3,200, yeah. And the really nice part is we're already going to know what the integral's worth at 3,000, so we only have to really do one part. Okay, what'd you get when you throw all that in?
90,000.
90,030? That worked out nice.
No. $90,000. 90,000.
And $30.
Oh, 30. Did that include the 30,000 or the $90,000 setup? Okay, so there's the actual marginal cost. This is a marginal cost. So this is what it would actually cost to make 0 to 3,000. Add in the fixed cost or the setup cost to get everything going, $180,030. Stupid thing, don't forget the dollar sign. Yes, you have to have it. Yes, that's your units on that. That would be your total cost, yep.
Wait, what is the $90,000 for?
Setup fee or development costs, something like that. Really, why they tell you that is they want you to understand what marginal cost is telling you and how marginal cost is different than total cost. So in other words, to buy the supplies, fire up the manufacturing line, actually make the first 3,000 cost 90,030. To get everything set up to even make that first one cost 90,000. So the total cost would be $180,030. Again, they're really, why they throw in that setup cost, just so you understand what these things tell you, not just how to do the algorithm. I know. All right, next one, part B. Now we need to find the marginal cost for the next 3,200. So we're going to take the integral from 3,000 to 3,200 of 120 minus 0.06x plus 0.00001. Because part B asks us to find the marginal cost of the next 200. So when we find this marginal cost, is that setup cost even going to be in there? Not at all, no. Nope, because we just want to find out how much does it cost to make 200 more, not how much does it cost to make the first 3,200. So we're just finding out, okay, so somebody says, I want you to make 200 more. We're trying to figure out, okay, how much is that going to cost us? So we have a function to model it. We then take the integral from 0 to 3,200, or from 3,000 to 3,200. That's just going to tell us how much 200 more would cost. If we don't sell those 200, we've already hopefully made money making the first 3,000. We don't have to consider those costs.
Okay, so this equation here, that's the C prime. Right?
That's the C prime, right?
So that tells us the amount of total cost.
How the cost is changing for each one we make. Like if you found C prime at 700, that's how much the 700th one would cost to make.
Okay, so the derivative of that is the actual cost.
Correct.
Between 2,000 and 3,200.
And I think you used the wrong word. The integral of that is the actual cost. Yes. And it's not total, though. It's the marginal. Yep.
Would this function C of x be?
C of xb would be your full cost equation. But we're not necessarily interested in that because we're looking at how much does it cost to make one more? How much is the cost changing at like the 700th? And again, you kind of have to put yourself in the spot. You've already sold 700 of these. Somebody says, hey, I want you to make 100 more. Okay, well, your costs are already sunk to make the first 700. You shouldn't include those to make the 700 to the 800th. So we're just saying, okay, how much is it going to cost me, the guy who owns the factory, to make 100 more? And then you price it based on that, not on the total cost to make the first 800. Okay, take the integral of that. The nice part is you already know what it's equal to at 3,000. So you really just have to find it at 3,200. Yep.
I got a bigger number for 3,000.
You should have got the same number for 3,000.
Oh, no,
Hold on. Where's my calculator?
32,000.
Somebody borrow my calculator.
3,200.
Josh, did you borrow it? No, I had a blue one up here at the start of the day.
I like this.
It's right here, Mr.
Oh, thank you. So here's how I'm going to do it. I'm going to plug it into the y equals, so I don't have to type it in twice. So 120x minus 0.03x squared plus okay, then I'm lazy, so I'm going to go to the table set, started at 3,000 and go up by 100. Go to, what's wrong here? Oh, inserted 3, haha. Oops. I meant to hit table, but I forgot to hit second. Okay, so there's my cost to make 3,000. There's my cost to make 3,200. So what's the difference between those two? Double check my math here. Did I check that in right?
Yeah, you are wrong.
What? Starch?
I got the same thing.
Well, yeah, see, I got 180, but they both got it. So I just-
Yeah, no.
Well, double check that.
Hold
Hold on. Let's check. Did I put this in right?
Wait,
Tara Storch, didn't my very first day teaching here at DCC, I trusted you for an answer off the calculator. My first day teaching pre-calc and it was wrong.
I don't.
I
Don't hold
One word, Australia.
Jeez,
That's
I'm
all I
so
say.
sorry,
One.
Mr.
No, just tell her. It's Brandon. Just tell her Australia. That's all. all you need to tell.
Wait, what?
Have you told Brandon that?
About what?
Australia? TAing on Tuesday?
Stop.
Okay.
Wait, why? What's your?
I'll tell you at the end of class.
No.
So,
Do you think that's
so what's the marginal cost between the two though?
No, I was.
6,027. Now again, if it's a calculator problem, do you actually have to do the integral by hand? No, look at that, especially if it's multiple choice. All right, volunteer, what do we do? Volunteer, what do we do? Oh, what? Okay, so cotangent. What's the rule for cotangent? We got to take -1 over 1 plus u squared, so that whole thing squared, times du dx. What's the derivative of that? Is it just 8x? Yeah, don't forget, they're still integrals, even though we've been doing derivatives. Clean it up a little bit. Ahem. The students who are complaining about getting off task are now off task. Some people. No, look at Call paying attention over there.
Yeah, I know.
Okay, stop and check out. Questions on that? Okay, so let's get these out here so we can then pick up with them on two of the rules for integrals of these. The rules for integrals of these. If you have the integral of the square root of a squared minus u squared, ahem. So again, what does that feel like? It's the square root of a squared minus u squared. Okay, that feels like a sine. That's equal to the arc sine of u over a plus c. Now, it's kind of funny, but there's no expectation that you know the arc cosine one for the AP test. So the next, I don't make the rules, I'm just telling you what they are. I don't make the rules, I'm just telling you what they are. Yeah, you do have to know arc secant.
I decided to give us a break on arc cosine.
I have a feeling like it has to do with the level of challenge required for it, but if you have a u times, now notice you've got your function first instead of your function second. Du over u times the square root of u squared minus a squared, that's going to give you 1 over a times the arc secant. Remember, you took the derivative of secant, it had an absolute value. The integral of arc secant is going to have an absolute value too, because it has to stay positive for this to be true. Notice in this one too, a is in the denominator twice of that one. And then the last one you're expected to know, say you had du of the square, no square root on this one, a squared plus u squared. That's equal to 1 over a times the arctan of u over a, yep, plus c.
Is it absolute value?
No, absolute value because we're going the other way. We're taking the integral, not the derivative. And tangent did not have an absolute value in it. Tangent, remember, just 1 plus u squared. Okay, so the keys for this. This is what you got to kind of identify. You have to identify what is u equal to, what is a equal to, and then find what du is equal to as well. So the first thing I try to do in these, okay, what form are they in? Are they in this one, or this one? Obviously, if there's no square root, that's what we're looking for there. If there's something outside, more than likely, we're going to try this first. If there's just two things inside, we're going to try those first. So let us take a look at example 2. Let's go for the integral of, what's that? I'm just going to give you an easier one first. Let's give you an easier one first. Let's go for x squared times the square root of x squared minus 9. And what do we have to make the top? We have to make the top 4x. What's that? Absolutely, because remember, all of those have a du on top. So you have to make sure whatever u is, you have its derivative on top.
How do you find out what u is?
That is going to involve some guessing and checking. You're going to try what u is first. Okay, let me make S1 a little bit easier. Let's try. Let's just make this a 1 on top. Fine, we'll make it a 1 on top, make it easier. And let's make that, hold on just a second. Whoa. Stop talking, Storch. Storch, stop talking. That'll have to just be an X there then for that to work out. Fine, easy. What's that? We got 1 minute. Okay, so easy part. What's u equal to in this case then? Okay, now here's the hard part. Notice in the equation, it's not u, it's u squared. So it has to be whatever u is squared. So don't think of it as what the squared is. What would be squared is underneath there. So u would be equal to x. So then what's du equal to? 1. That's nice. That's how we make that easy. What's a equal to? Don't say 9. 3. Again, it has to be squared in there. It has to be 3 because 3 squared fits it. So then what do we have? We have u squared minus a squared, and we have du on top. So what is that equal to then? It's 1 over a. A is equal to 3. And notice how I write these down below. That's on purpose. 1 over 3 times the arcsecant of the absolute value of x over a, and then a duh thing, but don't forget to put what?
Plus C.
Plus c, because it's a what?
Indefinite.
It's indefinite.
Wait, so if it doesn't work out nicely, then you have to do something that we did with the other integrals, we like multiply.
Yep. And we'll start with a couple of those. So your test will be on Thursday because I'll cover hyperbolics on Tuesday.
I'm not gonna
And that's a big one.
do the test.
I'll text out the homework after I'm done 7 for Brian.